Beginning in Unit 3, the first standard you're going to work on deals with arithmetic sequences. A sequence is an arrangement of numbers or objects that follows a rule or a pattern. Take a look at the Fibonacci sequence. 1 to 2, you add those two together, you get 3. 2 plus 3, you get 5. 5 plus 3, 8. And so on and so forth. That is a pattern. A sequence is a pattern that follows a rule. Each term in the sequence is called a term. The pattern of the Fibonacci sequence is that each term is equal to the sum of the two previous terms. This rule is an example of using recursive process because finding a term depends on knowing previous terms. When defining a recursive process, you must define at least one previous term. The variable a is often used to stand for the terms in a sequence. The first term, a1, and that's a lower 1. The sequence is a lower 2, and so on and so forth. The nth term of the sequence is written as where n can be any positive integer. This notation is used for writing the sequence rules mathematically. The equations below represent the rule for the Fibonacci sequence. In an arithmetic sequence, each term is found by adding a fixed number called the common difference, which is represented as d, to the previous term. The arithmetic sequence 3 to 5, 7, 9, 11, 13 has a common difference of 2 because you are adding 2 each time to get to the next number. If you know any term in an arithmetic sequence, you can add the common difference to it to find the next term. The following equation is a recursive definition of an arithmetic sequence. You can get an equation to find any term in an arithmetic sequence. In my opinion, this is my favorite way to do it. As long as you know the first and you know the common difference. So you know the common difference and you know the first term. This is my favorite because it works for any number. You can find any desired term in a sequence. Example 1. Below are the first 4 terms in an arithmetic sequence. First step, find the common difference. As you can tell, the common difference is -3. You're subtracting 3 each time. So D is equivalent to -3 in this problem. And also, 25 will be considered a 1. Now, let's say I wanted to write an equation, okay? And I go a1 plus n minus 1 times d. Okay, that's the equation I want to use. And I want to find since we know it's 16, let's find the 4th term in the sequence. So we go a1, which is 25, so let's plug that in. 25 plus nth term, 4 minus 1, times -3. Parentheses first, 25 plus 3 times -3. And I get 25 minus 9, and I get 16. 16 is the 4th term, so we know the equation is right. So the equation I would use would be 25 plus n minus 1 times -3. And that can work for any nth term. In a certain arithmetic sequence, each term is found by subtracting 4.5. Okay, so there's your D right there from the previous term. If the first term in the sequence is 10, what is the 9th term in the sequence? So my first step is to write the equation. 10 plus n minus 1 times -4.5 because we are subtracting. Now I'm looking for the 9th term. So I'm going to plug that in. 10 plus 9 minus 1 times -4.5. 10 plus 8 times -4.5. 8 times 4.5. And I get 36. So I get 10 minus 36. And I get -26. So with that, in that sequence, the 9th term would be -26.